Hi there, this is Miriam Pirtle. This is for Mr. Melville's grade 12 advanced functions course. We're going to be exploring a rational function. And a rational function is a function in the form of a fraction. So we're going to be exploring one in particular, and it's the function x squared minus 6x plus 5, this is our top piece, over x squared minus 2x minus 3. So this is our equation. We're going to graph it and explore all its properties and everything like that. So first off, we want to put it into factored form. This is going to help us determine the zeros, the vertical asymptotes as well, and help us really visualize what this is going to look like. So first of all, let's factor this. So the top piece we need to factor, and so we need a number that multiplies to 5 and adds to -6. So two numbers that come to mind are x minus 5 and x minus 1. So there's our top piece factored. The bottom piece, we need a number that multiplies to -3 and adds to -2. Another number that would come to mind for this would be x minus 3, x plus 1. So there we have our factored form of the equation. And this is the best form to have it in. It's going to help us a lot in determining the zeros and the asymptotes. So first of all, we want to determine the zeros. This is where it intersects with the x-axis. So the top piece here is going to show us where these zeros are. So what x values would cause the numerator to equal 0. So 5 minus 5 would equal 0, and 1 minus 1 would equal 0. So we know that our zeros are going to be 5 and 1. So when x equals 5 or 1, this is where the zeros are going to occur on the graph. And this will help us kind of visualize where what this graph is going to look like. Next, we're going to determine the vertical asymptotes. So the portion of the equation that is going to help us determine the vertical asymptotes is the bottom half, the denominator. And an asymptote is a value that the equation cannot equal. So a number that the equation cannot equal would cause the bottom, the denominator, to equal 0, which would make an undefined equation, or y value. So a number that would make the bottom equal 0 would be 3, or -1, causing one of these portions to be 0, making this equation undefined. So we know that our vertical asymptotes would be x equals 3 and x equals -1. Hi there. Now that we know that the vertical asymptotes are x equals 3 and x equals -1, this can help us determine the domain of our function. So a vertical asymptote means these values, these x values, we can't have them. So the domain is x is an element of the reals, but we know that x cannot equal 3, and x cannot equal -1, since these are vertical asymptotes. Next, we're going to determine where our equation, x squared minus 6x plus 5 over x squared minus 2x minus 3 is, we want to determine when it is greater than 0 and when it's less than 0. So this will help us also in visualizing the graph and understanding it. So first we have to take our important values. So our zeros, which we know were 5 and 1, and our vertical asymptotes, which we know were 3 and negative 1. So we're going to put these into a sort of chart, but first we have to order them from smallest to greatest. So we have negative 1, 1, 3, and 5. So we're going to put them in a table when x is less than negative 1, when x is between negative 1 and 1, when x is between 1 and 3, when x is between 3 and 5, and when x is greater than 5. And this will help us determine when this equation is greater than 0, so above the x-axis. So this is what the chart is going to look like here. And so we're going to plug in a value first off when x is less than negative 1. So let's pick negative 2. So negative 2 minus 5 is going to be a negative value, negative 7. So we're going to put that in there. Next we're going to do when x is less than negative 1. We know that is, so negative 2, we're going with that. Minus 1 is still a negative number. Negative 2 minus 3, negative number. Negative 2 plus 1 is still a negative number. So now we're going to pick a value between negative 1 and 1. So let's go with 0. So 0 minus 5, negative number. 0 minus 1, negative number. 0 minus 3, another negative. 0 plus 1 is a positive number. And then a number between, now we're going to pick a number between 1 and 3. So a good number would be 2, a nice number. So 2 minus 5 is a negative number. 2 minus 1 is a positive number. 2 minus 3 is a negative number. And 2 plus 1 is a positive number. Next, we're going to pick a value between 3 and 5. So let's go with 4. 4 minus 5 is a negative number. 4 minus 1 is a positive number. 4 minus 3 is another positive number. And 4 plus 1 is a positive number. Lastly, we're going to pick a number that is greater than 5. So let's go with 6. So 6 minus 5 is a positive number. 6 minus 1, positive number. 6 minus 3, positive number. 6 plus 1 is another positive number. So now we have to kind of multiply these out, like in their columns. So a negative times a negative times a negative times a negative equals a positive, since there's an even number of negatives. So we have a positive down here. Next, a negative times a negative times a negative times a positive is going to equal negative, since there is a odd amount of negatives. This one, there's an even amount of negatives, so we're going to have a positive value. This one, there's an odd amount, so we're going to have a negative value. And this one is going to be positive, since they're all positive. So this bottom column is the most important here. It helps determine where x is greater than 0, which was what we were trying to determine in the first place. So all these positive values are going to help determine that. So we know the y-intercept is when x equals 0. So we're going to set x equal to 0. So we're going to calculate f of 0. So we're going to be 0 squared minus 6 times 0 plus 5 over 0 squared minus 2 times 0 minus 3. So we know this value and this value are going to equal 0, and this value are also going to equal 0. So we're left with just these two values on the edge here, and they are going to be our y-intercept. The last thing we need to know before we graph is our horizontal asymptote. So we determine this by looking at these first x values here, and we're noticing that the degree is the same in both of them. They're both to the power of 2. So we know that this there's going to be a horizontal asymptote, and the coefficients here, they're not written, but they're 1 and 1. So 1 divided by 1 is 1. So we know that our horizontal asymptote is y equals 1. The last thing we're going to do before we graph is just list everything that we've kind of found out using the equation. So first we're going to look at the domain. So we determined that x is an element of the reals, but x cannot equal 3 and x cannot equal -1. We discovered this by determining our vertical asymptotes. Our intercepts, our y-intercept, we set x equal to 0, and we determined that that it would go through the y-axis at negative 5 over 3. And then our x-intercepts, our zeros or roots, are at 5 and 1. And we determined when the line was above the x-axis by using that chart. And so we determined when x is less than -1, it's going to be above the x-axis. And when x is between 1 and 3, it's going to be above the x-axis. And also when x is greater than 5. So our asymptotes, they're very important. Our vertical asymptote is 3 and -1. And we determine that using the zeros of the denominator. And the horizontal asymptote is 1. Okay, so here's our graph. This is finally what it looks like. We did this using graphing technology, and we can identify all the points that we determined earlier. So you can see the zeros at 5 and 1. You can see the y-intercept here at -5 over 3. You can see the vertical asymptote at x equals 3. You can see the other vertical asymptote at x equals -1. You can see the horizontal asymptote right here across at 1, at y equals 1. But you'll notice that the line actually goes through the horizontal asymptote, which doesn't seem to make sense since an asymptote implies that it does not reach this value ever. But that only applies to the extreme values. Thanks for listening.